Let's look at the solutions to practice quiz version B. So this first one we are supposed to simplify. So we have to do this exponent on top first. So that's 5 to the 4th. And then when you raise a power to a power, you multiply. So 3 halves times 4 is 3 halves times 4 over 1. That's 6. So 3 halves times 4 is 6. X to the 6. Y to the negative 8. And then I'm going to write 25 as 5 squared. And then I've got x squared and y to the negative 3. So I can cancel 2 of those 5's out. So that gets me 25. And then 6 minus 2 is 4. And negative 8 minus negative 3 is negative 5. And then to not have any negative exponents, I'd write that as 25 x to the 4th over y to the 5th. 25x to the 4th over y to the 5th is the right answer. An exponential function f of x equals cb to the x passes through 0, 6, and 348. Okay, so if it passes through 0, 6, that's x equals 0, and f of x equals 6. So if I had f of x equals cb to the x, that gets me 6 equals c times b to the 0. B to the 0 is 1, so 6 is equal to c. So now I know that f of x equals 6b to the x because 6c is 6. And now from 348, I know that when x is 3, f of x is 48. So I've got 48 equals 6 times b to the 3rd. Now I'll divide both sides by 6. And I get 8 is b to the 3rd. So what number raised to the 3rd power gives us 8? That's 2. So b is 2. And so our function f of x equals 6 times 2 to the x. Six times 2 to the x. Yep. Write an equation obtained from y equals e to the x by translating the graph 3 units to the right and then reflecting it across the x-axis. Okay, so that's not e to the x. Yeah, that's e to the x. Crosses at 1. Okay, so 3 units to the right. So e to the x is 1, and at 1 it's supposed to be at e. So 3 units to the right means at 3 it would be at 1. And at 4 it would be at e. And then we're reflecting it about the x-axis. Okay, so that would be y equals e to the x minus 3. And then to reflect it, well, actually, let me put that here. Y equals x e to the x minus 3, and then to reflect it about the x-axis, it's minus e to the x minus 3. Now I want to show you something. let's say I reflect, I've got y equals e to the x, and then I reflect about the y-axis. That'd be y equals e to the minus x. Okay, and then if I shift it right by 3, that'd be y equals e raised to the minus, and then open parentheses, x, and I'm shifting to the right, minus 3. So when I reflected first, I put the minus 3 in parentheses. If I shift first and then reflect, then I just put the minus with the x. So for example, if first I shift to the right by 3, so I have y equals e raised to the x minus 3. So I shifted to the right by 3. Now if I want to reflect that about the y-axis, notice it'll be on the other side of the axis, and so I just put the minus sign with the x. So it's y equals e raised to the minus x minus 3, but the minus is not outside the parentheses, it's just negative x minus 3. So that's if I shift first and then reflect about the y-axis. But the problem on the practice quiz was about the x-axis. With the x-axis, it goes in front of the whole thing, so it doesn't matter. Combine into a single logarithm. Okay, well, we know that numbers in front can come up as exponents. So this is log x plus 1 squared. It's a common log, so I'm not going to write the 10 because I'm lazy. Minus log 10, and raising something to the 1/2 is the same as a square root, so x minus 4. This is a minus, so that means divide, so this is log x plus 1 squared over the square root of x minus 4. Yep. Okay, solve for x, exact form, and a decimal to 3 places. So I have 5 to the x plus 1 equals 120. You could do this with log. Let's just use natural log because that's going to be what you'd be expected to do. So this would be the natural log of 5 to the 2x plus 1 equals the natural log of 120. So I'll take the natural log of both sides. Then you bring the exponent down in front. So I get 2x plus 1. Don't forget parentheses because this whole thing is multiplied times the natural log of 5 equals the natural log of 120. Now I'll divide both sides by the natural log of 5. And I get 2x plus 1 equals the natural log of 120 divided by the natural log of 5. Now you cannot divide the 120 by 5. You can't do that. There's nothing to be done to simplify that. And then I'll subtract 1 from both sides. So I get the natural log of 120 over the natural log of 5 minus 1. And then I'll divide everything by 2. So I have the natural log of 120 divided by the natural log of 5 minus 1 all over 2. That's a bit cumbersome, so you might write 1/2 times the natural log of 120 over the natural log of 5 minus 1. It's another way to write it. And then, before I do that on a calculator, let me see if that is what they have. They use log base 5. I'll show you how to do that in a minute. Okay, so with natural log, so I would have natural log 120 over natural log 5. That whole thing minus 1 all over 2. 0.987. 0.987. Now the calculators that you'll be using in 1550 don't have a log base, but if you do have a calculator with a log base, there's another way to do this. So we're starting with 5 to the 2x plus 1 equals 120. So I can take the log base 5 of both sides, and log base 5 and 5 raised to a power, those are inverse functions, so they cancel each other out, and you get 2, this should have been log base 5 of 120. 2x plus 1 equals log base 5 of 120. Then subtract 1 from both sides. 2x equals log base 5 of 120 minus 1. Or x equals log base 5 of 120 minus 1 over 2. And then on the calculator, log base 5 of 120 minus 1 divided by 2 0.987. So that's just another way to do it. Neither one is better than the other. And that's that.